Hi guys, my name is Lorena Ujo, and today I'm with Camilo Tapias and Mauricio de Moya to talk to you about offshore production platforms. The following are the items to discuss in this presentation. First, we have the introduction and history. Second, definition and main features. Third, type of oil platforms. And finally, platform design. Well, what do you think an oil platform is? Well, an oil platform is really a large structure whose function is to extract oil and natural gas from the seabed deposits. Most platforms are portable, drill a well and offshore site, and then move to drill elsewhere. Now, talking a little bit about the history of the oil rigs, we can find that the first offshore oil well was in 1846 in Bibi Heibat in Baku, Azerbaijan. The first well found under the surface of the water was in Ohio, with wounded platforms and steel. But 5 years later, the first saltwater extraction was made in Summerland, California. We were made from docks that extended to the connection point. Then, in Azerbaijan, around 1915 and 1916, the first natural gas farms were carried out with submerged pumps. Following this, were drilling over the coast of the Gulf of Mexico, specifically in Louisiana, around 1903, and was operated in 1918 with an offshore platform producing more than 150 million barrels until 2006, with a lifespan of approximately 19 years. There are currently more than 15 operating companies providing platform services. In the chart, we can see the top of the main operators and the number of offshore platforms of each. At this point, it's necessary to clarify that oil platforms can perform different functions depending on the stage of the project. Recalling the stage quickly, we have the opportunities identifications, the first, then exploration, and finally the production. After mentioning the stage, it should be emphasized that in this case, we will focus on the production stage, that is, on the oil platforms in the production stage. The production stage consists in the exploration of hydrocarbon found in the oil field. This moment marks a turning point in terms of a project flow, because from now on, the money you will pay for past investment is generated, but also those that move the new projects. When the well is new, the flow of crude oil to surface is usually natural, caused by the pressure difference, but as the exploitation progresses, the flow rates decrease to the point where artificial extraction methods are needed. Now, there are three main types of natural throws. Number one, push by dissolved gas. The driving force is the gas dissolved in oil that tend to escape and expand due to decreased pressure. The final recovery is usually less than 20%. Second, we have pushed a layer of gas. When the gas accumulated over the oil and immediately under the roof of the truck generates a push on the oil towards the well, and recovery of the gas content file is to 40 to 50%. And finally, we have the hydrostatic thrust. The most efficient driving force to cause oil to be expelled from the reservoir is the thrust that of the accumulated water under the oil. Recovery in a deposit with this type thrust can reach 60%.
Well, my name is Camilo Tapias, and let's talk about the main offshore oil production platforms. First, I began talk about the tensional lead platform or TLP. In the water reservoirs, tensional lead platform has been developed to generate the economic potential of new discovery. They are used for drilling in waters with depth greater than 600 meters. They are supported by anchor cable fixed to the seabed and held on the surface by floating columns. Its installation is very simple, since it doesn't require crane barges and has great stability in adverse water conditions. While semi-submersible units and drillships are used only for drilling, TLPS tension-led platform has a great advantages in versatility to drill, recover, and produce wells almost simultaneously. The GLP is a system similar to the semi-submersible platform, except that it is anchored to the bottom by means of vertical elements, which are kept in tension due to excess flotation in the platform. It presents a mixed behavior, being tolerant with the horizontal degrees of freedom, and in turn thrives with the vertical degrees of freedom. Since the vertical balance of the platform is achieved by keeping the tension tempered by the excess flow of the hull. The tension load is transferred to the foundation system through the tensioners that make up its mooring system. The turnbuckles are anchored to the sailboat by means of a structure made from structural steel and assembled by piles. Second, the marine physics equipment. In the shallow waters, it is technically feasible to seal the oil platform to the sailboat. This being the reason for calling them physics platform. The columns that support the decks with the production equipment and facilities can be made of concrete or steel, which in the front of lead or left from the surface platform to the top. Here they are fixed with larger concrete structures. The platforms are projected to receive all the drilling equipment, material storage, staff accommodation, as well as the facilities necessary for the production of the wells. This platform sit where the productive life of the wells is going to be very long lasting. The advantages of these platforms are their high stability and load capacity, as well as their low movements in the face of meteorological and oceanographic actions. In recent years, Faces platform has represented the most common structural solution for production and drilling ensembles. However, drilling works in depths greater than 400 meters are not productive. Since it is no profile to build and install a physics platform with so heavy and long substructure to learn on the civil. Physics platform complexes are generally made up of different modules. The most important are drilling, production, or housing. The parts are manufactured separately on land and later moved and placed in their final location. Third, we have the Spark platform. Technological advances now made it possible to extract gas and oil from very deep waters. The platform called Spark have been developed as an alternative to the traditional ones and are used in very deep waters, about 1,500 to 2,000 meters depth. Although, although there are several types of the Spark platform, traditional, truss, or cell. Basically, a Spark platform consists of a larger cylinder. The light buoy provides the necessary buoyancy. The concept is similar to that of an iceberg, as most of the cylinder is submerged. This reduces the center of gravity of the structure, making it more stable to winds, waves, and tides. Filling part of the cylinder with a liquid that is denser than water is what allows to obtain a center of gravity lower than the floating points. The cylinders are usually accompanied by a external spiral structure that provides more stability. This spiral partly eliminated the turbulence that the large cylinder can generate in the water by directing the flow through the spiral so that there are no eddies on the opposite side of the current. In the fourth position, we have a floating production story and offloading, FPSO. These floating units are generally used in traditional offshore hydrocarbons production fields when connected to onshore facilities with a true line of pipelines is not possible. In them, the hydrocarbons produced are not only processed but also stored for a certain time until a transship vessel unloads it to take it ashore. FPSOs are very useful in reservoirs in the early stage of production where in addition to the absence of the pipelines infrastructure, the definitive wells tests have not been completed. In this case, once the production and transportation infrastructure is fully developed, the FPSO can be installed in a new production field at an early stage of development or in another marginal field. Most FPSO have been built by retrofitting and converting large tankers that have dynamic position systems. These systems allows a boat to maintain a certain position or direction using its own thruster and permanently measuring and comparing its position with respect to the reference position. The floating production story offloading FPSO I mentioned before. And then we have the cell lighting platform, jackups. This is the first production unit par excellence. It is a three-dimensional lattice supported on four legs with cylindrical tubulars to prevent buckling. The average depth at which they are installed is 100 meters. This is a kind of the special device used for production, drilling, and repair of wells. It has the ability to move from one location to another by self-propelled or by towboats. Thus, drilling is its main function, whether for exploration or development wells. Once in the desired position, the legs are lowered until they reach the seabed, when the columns or legs are seated on the seabed. The deck is raised beyond the water level until there is a stable platform.
I'm going to talk about the one of the most complex construction for offshore exploitation. Condeep is an English word that names the structural, typological, and deep water concrete oil platforms. Condeep is about GBS, gravity-based structure system, offshore platforms that are designed to be implanted below the seabed have generally been constructed of reinforced and pre-stressed concrete, but a few have been constructed of steel of hybrid for concrete and steel. Next, I present the different stages necessary for the construction and location of concrete platforms. Dry dock construction, base construction, float out, construction tie, axle constructions, deep sea trailer, deep construction and location, submarine immersion, cover copy, trailer in the installation sites, and dock installation. The first stage, the construction of deep docks, and the base is the place is similar to the docks where the boats are maintained. The area must be isolated from water, and the sea planks supported by artificial constructed sand cornices. Float out. With the frames ready to float, displacement checks are performed to ensure the flotation can be achieved within the draft and the wheel's design tolerance. When the folding of the base is complete, the ballast water is removed from the cells and the base float. The remaining construction activities from the platform are be taking place within the structure is moored, but the athlete protected. During this period, the structure must be protected against the accidental flooding. There should be detailed examination during construction, as temporary unblazed loads will translate into the structural stress. Next stage is typical the construction of the axles, which can be typical 1 to 4 in number. They are usually conical with a different wall thickness, making it necessary to use the sophisticated shape. Deep water trailer for the desk location. Upon researching the site, the structure must be weighed down to the sea floor. The boats that tow it must keep the platform in place. This is where the structure came in hand, allowing the boats to select its course within the need to exist traction. The final structural operation is the sites to the installation to the conducts. These have usually been transported with the frames and relay establishment to the conductive gates. The conductive that penetrate that lower slab have internal and external mechanical coats that are cased that avoid any possibility to failure.